Dear children, now let's learn the second part of the lesson. To make this success, you have to take your grade 11 textbook with you. And also you have to refresh the grade 10 knowledge about bond formation. If you cannot remember the bond formation, please watch my grade 10 lessons. As given you have to achieve these learning outcomes at the end of this lesson. Remember, you are learning these things in one way to practice them in your day-to-day life, and in another way to answer the questions at the end of the year. So that I hope to send my third video to discuss the past paper questions related to this topic. As I mentioned in the first video, homogeneous mixtures also can be referred as solutions. In a solution, there are two components, namely as solutes and solvents. What is a solute? Solute is the dissolved matter in any solution or mixture. In Sinhala, it is called as ද්‍රව්‍යය. ද්‍රව්‍යය යනු ද්‍රාවකයේ කැටි ද්‍රව්‍ය ප්‍රමාණයයි. What is the solvent? Solvent can be in liquid and gaseous state, and that led to dissolve any other liquid, solid or gas. Therefore, a solution can be defined as the homogeneous mixture of two or more substances. When referring the chemistry related books, you may have come across with the symbol of AQ. That refers to the term aqueous solution. Before moving to the main topic, let's have some idea about aqueous solution and non-aqueous solution. Aqueous is water. Aqueous solution is a solution in which the solvent is water. You have been learning the properties of water since grade 6. There you learned that water as a universal solvent. That means many of the substances easily dissolve in water. But there are some substances that cannot dissolve in water. They dissolve in any other solvent than a water. So, the aqueous solutions are the solution in which the solvent is water. Non-aqueous solution is a solution in which water is not the solvent. As an example, you know that paraffin wax won't dissolve in water, but it will dissolve in kerosene oil. Naphthalene also the same. So, there are certain solvents that are not water. So, anything that can be dissolved in such a solvent and make a solution, that is called non-aqueous solution. Now let's move to the main topic. What are the characters of a solution or the homogeneous mixture? They are homogeneous mixtures. When you filter a solution using a filter paper, no solutes remain on the filter paper. That means all particles being filtered easily. Solutions are either colorless or may be colored. If it is a colored solution, the color is distributed evenly throughout the solution. When you send a beam of light through a homogeneous mixture, you cannot see any scattering of light. That means you cannot see the path of the light through the homogeneous mixture. But you can see the path of the light through a heterogeneous mixture, because these particles let the light beam to scatter into. And also another important fact is that we cannot separate solutes from a solvent by using simple filter method. If it is a homogeneous solution, The particles of the solutes are not visible to the naked eye. Now move to the main topic, solubility. To take a hands-on experience, try to do the activities on page 35 and page 36. You can do these practicals or the activities at home very easily. Please try it by yourself. Don't wait till the schools reopens. You can do them and get the hands-on experience by yourself. Here in this activity, you are asked to get the 100 grams of salt and 100 milliliters of water. First, measure them separately. I will teach you how to measure them in an approximate way by using the household measuring utensils. Example, you can measure 15 grams of any solute by using your teaspoon. 3 teaspoons equals to 1 tablespoon, and that is equal to 15 grams. That means 1 teaspoon contains 50 grams of any substance. So to get 100 grams of table salt, you have to take 20 teaspoons of salts. So you have to measure roughly and keep it aside, and then measure water by using your teacup. Teacup holds 250 milliliters of water. So take 4 cups of water. That gives you 100 milliliters of water. So take them separately and put water into a jug, and teaspoon by teaspoon add this table salt into the 100 ml water jug. And remember, you have to add at a small amount at a time and stir them well. You should not add until all the solutes get dissolved. When you do this, continue this activity, then you will be able to see that small undissolved salt particles on the bottom of the jar. At that time, you have to stop adding and get the rough idea about the remaining table salt that with you. And also then thereby by subtracting that remaining portion, you can get an idea how much amount of table salt dissolved in 100 milliliters of water. Remember that 1 ml of water is equal to 1 gram of water. So you have to repeat the same activity by using hot water. Then you get an idea about this dissolved amount. Don't stop the activity there. So you can do the same activity by using sugar, some talc, that means your powder, calcium hydroxide powder, who knows, like anything that you do the same activity, repeat the same activity using different kinds of solutes. Then you will be able to observe that these substances dissolve in different amounts in this 100 ml water. Again, you have to repeat the same activities using hot water. Then you will be able to observe that amount dissolves increases with the temperature even within the same kind solute and same kind solvent. So that now we can define the term solubility by using the knowledge you had. Solubility is referred to the maximum amount of solute in grams that can be dissolved in 100 grams of water at a specific temperature and pressure. Here you have to know that 1 milliliter of water weighs 1 gram. So the given table indicates or gives you some examples of solubility of two substances in water. There you can understand that even within 25 degrees of centigrade, solubility of magnesium chloride in water is 53 grams and solubility of potassium sulfate in water is 12 grams. According to the amount of solutes dissolved in solution, we can come across with three types of solutions. The first one is saturated solution. Here, the solvent holds the maximum amount of solutes at the given temperature. How do you get to know the solution is saturated or not? If the solution is saturated, you will be able to observe that undissolved solute particles in the bottom of the flask. At that time, we said that the solution is saturated. The second one is unsaturated solution. The term gives you an idea that the solvent can hold some more solutes. That means it is dissolved less than the maximum amount of solutes for that particular temperature. Here you cannot see any undissolved particles at the bottom. What is supersaturated solution? Supersaturated, that means the solvent hold much more solutes than the saturated point. Here given some examples for the solubility of different solutes in different solvents in a particular temperature. If you look at the table carefully, you can see that some solute dissolve in certain solvents and the very same solute does not soluble in or slightly soluble in other solvents. Example, sugar. The solute sugar is insoluble in kerosene oil, coconut oil, ethyl alcohol. It is slightly soluble and highly soluble in water. Let's take the powdered chalk. It is insoluble in kerosene oil, insoluble in coconut oil, slightly soluble in ethyl alcohol and soluble in water. Likewise, if you go through the table carefully, you will be able to see the differences of solubility. This raises a question. That means there must some other factors also affect the solubility of the substance. The different solutes dissolve in different solvents even in the same temperature. So, we have to know about the factors affecting the solubility. What are these factors of solubility? Temperature, nature of the solute and the solvent, pressure for the solubility of gases. If we take these factors one by one, the first one is the temperature. Temperature is the major factor on solubility. You have already learned in grade 10 about the factors effect on rate of reaction also. You learned that higher the temperature, higher the rate of reaction. So in the same manner, when increase the temperature, that leads to increase the kinetic energy of the particle. That means particle motion increases. And as a result of that, it increases the diffusion of the solute particles into the solvent particles. Higher the diffusion, it will increase the dissolution. So higher the temperature, higher the kinetic energy, higher the diffusion, higher the dissolution. So in this slide, you can get a kind of understanding about how The solubility of different substances in different temperatures. The sodium chloride dissolved 57.7 grams in 0 degrees, 36 grams in 20 degrees, 37 grams in 50 degrees, and 39.8 grams in 100 degrees. So all these sodium hydroxide, copper sulfate also increases its solubility with the temperature. The second and third factor I took together, effect of nature of the solute and the solvent. To understand this, you have to refer the bond lesson in grade 10 textbook, or you have to watch my grade 10 video on bond formation. In chemical bonds, you have learnt about the polarity. We can divide the substances into polar and non-polar substances. And also according to the presence of chemical composition constituent, we know that compounds can be classified as organic and inorganic compounds. And also you have learnt about the ionic compounds and covalent compounds. So you have to refresh all these three to understand the solubility of the solutes and the solvents. Simply, what you have to understand is ionic compounds. That means the compounds that are having ionic bonds dissolve in polar solvents like water easily. Non-polar solutes dissolve in non-polar substances. This is the rule of like dissolves in like. It is simply explained in this slide. If you want more explanation, please refer the grade 10 work. In this table gives you the type of bond, solute and the solvent. Ionic compounds, that means example sodium chloride is ionic compound, highly soluble in polar solvents, insoluble in non-polar solvent. Polar covalent compounds such as sucrose, highly soluble in polar substances, insoluble in non-polar solvents. Non-polar covalent compounds like naphthalene, insoluble in water-like polar solvents, highly soluble in non-polar solvents. This gives you an idea that solubility depends on the nature of the solute and the solvent. For further clarification, let's learn about the solubility of ionic compound in polar solvent. So, as mentioned in the earlier slide, ionic compounds are highly soluble in polar solvents. The reason is the attraction between the charged ions with the polar molecules. In a polar solvent, you know that there is that in a water having slightly positive or delta positive and delta negative charge within the hydrogen and oxygen. So hydrogen is slightly positive and oxygen is slightly negative. So what is happening here? If you take the preparation of salt solution as an example, sodium chloride or salt is an ionic compound and water is a polar solvent. Sodium positive ions are attracted towards the slightly negative oxygen atom, and negatively charged chloride ions are attracted towards the slightly positive hydrogen ions. This attraction weakens the bonds between the particles of the ionic lattice. Ionic lattice means the sodium chloride crystal. And that resulted the dissolution of sodium chloride in water. So let's take the solubility of gases. If you learn the properties of gases, gases also can be categorized as polar gases and non-polar gases, but the polarity of them are different to each other. Accordingly, higher the polarity, it dissolves more, so that gases with polar bonds soluble in water and non-polar gases do not dissolve in water. With compared to solid substances, gaseous solutes dissolve less in high temperatures. Solubility of gases high in high pressure conditions, that is experienced by opening a soda bottle. Now think about the ways of increasing the solubility. With all this experience, you know that solubility in hot water is higher than the cold water or cool water or normal tap water. If the solutes are in powdered form, those are dissolved more than its crystalline form. And stirring also enhances the solubility. In my next video clip, I would like to discuss the past paper questions related to this lesson. So, collect the past papers or books and ready to revise it with me. Have a good day.